it's my pleasure to first briefly introduce the Joint Research Center to you, to those of you who haven't worked with the JRC yet. It represents one of the Directorates General of the European Commission. It's actually the in-house science service to the European Commission in support of the European policies. And the JRC consists of 7 institutes, out of which I am today representing the Institute for Energy and Transport, which is located both in Haehner, where we have the main site in the Netherlands, and in Ispra in Italy, where another 2 operational units of the institute are sited. If you look at the mission statement of our institute, it's to provide support to the European Union policies in the fields of energy and transport with respect to sustainable, safe, secure, clean energy and efficient transport. And it's clear that nuclear energy and nuclear safety in particular is also in the remit of our institute's activities. And in fact, to extend the mission statement, we should have a brief look at the recent interdisciplinary study on the benefits and limitations of nuclear fission for a low-carbon economy, and the symposium that has been organized a year ago on the nuclear fission research within the Euratom program of the European Union. And there it has been stated as one of the recommendations that the role of the Commission Joint Research Center as an EU center for nuclear safety, safeguards and security should be reinforced, in particular as regards the JRC's role in collecting and disseminating Euratom research results. And I will come back to this role of collecting, disseminating, aggregating research at the European level later on. So this brings me to the content of my presentation. I will give you a few examples very shortly, just to give you a flavor that we are also doing laboratory research into aging mechanisms. So here it's about physical aging mechanisms. But then I will talk about this to be enforced role to manage materials, data, manage results from European research projects, work on knowledge bases, on expert systems. I will give you examples for that in the field of aging. And then I will continue talking about human resources in the nuclear field, the Human Resource Observatory that we are running, and the implementation of the EC-VET, the European Credit System for Vocational Education and Training. And finally, I will briefly mention our previous role in the post-Fukushima European stress tests. Although this has not been addressed aging in particular, the conclusions drawn from there are important to be reiterated here. So just as an example of our laboratory effects, in the first presentation by Simone Moore, it has already been mentioned, corrosion and stress corrosion cracking are important issues. And in fact, we are dealing with a hierarchy of environmental factors that have to be taken into account. It starts with temperature, but then we have the mechanical loads, the stresses, we have the water chemistry to take into account, and eventually irradiation effects. And these are all interconnected and cannot easily be separated. So it takes a dedicated, specialized facility to look into these issues, and the message to take here is that at the JRC we do have state-of-the-art installations to investigate corrosion and stress corrosion cracking phenomena as applied to reactor internals, but also fuel cladding materials, which are the first barrier, so to say. Another example is specifically looking into irradiation effects and the embrittlement of reactor pressure vessel steels that has been mentioned before. We are currently carrying out a project looking into the alleged late blooming phases. What is this? there are indications that the embrittlement of RPV steels actually accelerates at very high Newton fluences of relevance to long-term operation and plant life extension. So we want to understand if this is really happening, if embrittlement really accelerates at a later stage in plant life, and what are the decisive factors in it, which elements in the steel would cause such a late blooming phases. In fact, we are carrying out now an irradiation experiment in the high flux reactor in Petten in collaboration with NRG, the Nuclear Research and Consultancy Group, to look into these effects. And just to give you an idea how complex such an experiment is, we have more than 600 specimens on board of this irradiation, from weldments, from the base metal of reactor pressure steels, but also model steels where we have deliberately changed the chemical composition of the steels to identify the critical elements. Another issue is, of course, standardization, and here we are contributing to benchmark exercises to develop test standards and also numerical evaluation schemes, for example, for weldments containing multi-metallic or different metals welded together, where no test standards exist so far. And of course, we cannot do this alone. We have to do this in a consortium involving many partners, parties involved in these assessments, and we are doing benchmark exercises in that respect. Thermal fatigue is another issue, very complex, because we talk about cyclic loading at various time scales. So it may come from turbulent mixing of fluids of different temperatures, but it may also come to low cycles with respect to the operation of the reactor, for example, in the case of load following. And we have dedicated test facilities to look into thermal fatigue issues, and in fact we have recently proposed a thermal fatigue test methodology in order to underpin the monitoring of critical components by laboratory experiments. Now, talking about aggregation of knowledge at the European level, we have just started up a new project to establish a knowledge base for aging mechanisms in order to consolidate and aggregate the knowledge created from various recent projects on these issues. And we do this in collaboration with the German JRC, die Gesellschaft für Reaktoranlagen und Werkesicherheit, which has already quite some experience in this field, and they have actually developed an expert system on this issue already, which we now want to take to the European level. So it's supposed to be an expert system for education and training, but also for, as I said, aggregating research done at the European level. JRC in Petten is also hosting the extensive surveillance database, which has originally been compiled by the agency, IAEA, but it was hardly accessible because it was PC-based. Now we have converted this into a web-enabled online database containing about 40,000 data sets from surveillance specimens from more than 100 reactor units in 7 countries. These data have now been transferred, and we are currently working at tools to assess the data directly online from the database, in particular using the so-called master curve approach, which is a standardized technique for evaluating reactor embrittlement. Data citation is another important issue because it's of no added value to create data silos that are hardly visible and nobody is using them. And we have not invented, but we are forerunners in using a new tool that's called data citation. Maybe you know the digital object identifiers that are being used for scientific publications. We do the same with data, with test data, in a way that researchers can be acknowledged in derivative works for the data they have provided. So this is a tool, a pilot, in order to promote European research and innovation with respect to sharing, aggregating, and reusing data. What we want to avoid is redundancy, duplication of tests, because nobody knows that the tests have already been done. So we have to give a certain visibility to the data. This, of course, does not infringe the confidentiality that, or the IPR that the data owner will have. So it's important to know that JRC is also at the forefront there with respect to the open data initiative of Horizon 2020. Talking about human resources, further to the recommendation in the 2009 Nuclear Safety Directive, we have established in 2011 the European Human Resource Observatory in the nuclear field, ERON, actually built on previous activities within the NF, Working Group Risk, Sub-Working Group Education and Training. Actually, JRC is the operating agent for this Human Resource Observatory, which is steered by a senior advisory group consisting of a multitude of stakeholders, vendors, utilities, TSOs, but of course also academia and national research centers. If you want to know more about the output of this Human Resource Observatory, please refer to the webpage where you can download all the reports that have been issued recently. The main challenges that derive from this work that the nuclear field is facing is, of course, these large-scale retirements in the nuclear workforce. But there are other problems. There's a problem with the attractiveness for new students to work in the nuclear field, and even more worrisome, there are the recognition of skills across European borders is not at its best. And this is why the mobility of experts is impeded. And due to this finding, which is based on our activity to compare supply and demand of experts in the nuclear field. Due to this finding, we are also working on the implementation of the EC-VET, the European Credit System for Vocational Education and Training, and in fact JRC is the facilitator for its implementation in the nuclear field, which is one of the most advanced fields, together with aeronautics, I would say, where this EC-VET system has already been advanced to quite some advanced stage. The main paradigm shift is from knowledge to skills and attitudes. What does it mean? You can easily circumscribe this by the question, what can you do now that you have obtained your degree, rather than the old or previous question, what did you do to obtain your degree? And following this leitmotif, we are looking into learning outcomes, in particular in the nuclear field. There are various reports on this available. Again, I refer you to the website of ERON. But what I want to stress here is that we have recently issued a database and an expert system for the employment education, containing a job taxonomy of more than 150 job descriptions and more than 4,000 learning outcomes of relevance to the nuclear workforce. So this is how we are advancing the implementation of EC-VET, and in order to remove mobility issues in the nuclear workforce. Finally, a few words on the stress tests. It has been mentioned that there's the EU clearinghouse for operational experience feedback, which JRC is operating in collaboration with TSOs, IRSN and JRS. And as such, we have been involved in the post-Fukushima EU stress tests. We have provided the secretariat for the stress tests. We have provided experts to do both or contribute to the topical reviews as well as the country specific reviews, answering to European Parliament questions and so on. And why do I mention this here? Of course, while the stress tests did not address aging specifically, they have clearly revealed that there is no clear correlation between the age of a nuclear power plant and its safety performance. They have rather shown the importance, and this has been mentioned by Mr. Minaj before, they have rather shown the importance of the periodic safety reviews in order to keep track and advance the periodic upgrading of replaceable components, of obsolescent instrumentation, and so on. And this is also to be taken into, it has to be taken into account that the design and of the nuclear power plants has evolved a lot during the last 3 decades. In doing so, it has largely contributed to the improved safety of the European plants, which are, I think, among the top worldwide.